This is the Stiebel Eltron heat pump combination solar system that I want to give a bit of a demonstration about. We can start off here with the heat pump. The heat pump works independently of the solar system, and the solar system works independently of the heat pump. You could buy or purchase this machine without the solar heat exchanger in the bottom, and this thing could by itself generate your hot water for your house. The heat pump that you're looking at over at the top here consists of a refrigeration section up in the top part, and the bottom section that you're looking at over here with the tank is a 300-litre vessel on the inside. The top part, the refrigeration system that we're looking at over here, consists of a single compressor and an evaporator on the side. What we do, we take the warm air that we're busy breathing in right now, we draft it through the refrigeration system. The heat transfers from the air into the refrigeration system, and once we've absorbed that heat out of the air, it gets expelled on this side here a lot cooler. Now the difference between the warm air going in here and the cold air coming out on this side here, that energy we've harnessed and we transfer it with gas pipes down in the bottom around the walls of the tank. Let's give a bit of an introduction. Alright, those gas pipes are wrapped with a heat exchanger around the walls of the tank. So in the bottom, once the heat gets transferred through the walls or through the pipes, that heat transfers through the wall of the tank into the water. There is no contact between the refrigerant and the water inside this tank, keeping it an absolutely pure system. You will never have maintenance because you never have to circulate water to a heat pump and back. Circulation pumps, there are no circulation pumps that transfer the water to the heat pump and back as in normal conventional heat pump systems. Which means it's less maintenance, and it also consumes less energy from the grid because you don't have any circulation pumps. Also, if you keep the two systems together and you put or if you keep them insulated in one unit, you also have less heat losses between the heat pump and the tank. This is the most efficient, or this is as close as you're going to get to a pure refrigeration heat pump system. When people talk about a 75% heat pump saving, this is for an ideal refrigeration system. The 75% is a theoretical saving when you've got an integral heat pump. The minute I take my heat pump and I split it and I put the tank separately like this, your efficiency drops because of the circulation of the water to the heat pump and back. To give an idea of how efficient a heat pump system is when you combine it in an integral unit, if you can have a look here on this side, this heat pump consumes 0.4 kilowatt to heat up 300 litres of hot water. Now that on its own is amazing. If you're not very technical, to give you an idea, 0.4 kilowatt would be the same as 4 light globes in your house to heat up 300 litres of water. This heat pump connects with a plug, a 3-pin plug here to the wall. When we import these machines, they actually come with a European 2-pin plug that you would buy if you buy a house light or a lamp or something else, or like a small fridge, a bar fridge. But with that we are heating up 300 litres. If you compare it to a South African local geyser, you would be looking at 3 kilowatts to heat up 150 litres. That is 3 times the power consumption, and this machine is doing double the volume. Okay, to make the system even more economical, we have combined it with solar to save on that 0.44 kilowatt that this client's using. He wanted to go away from Eskom as far as possible, or to go away from consuming any energy, and this is as close as we could come. We've supplied a solar panel with a heat exchanger already pre-built in here from the manufacturer. They've actually cast it in, or they've actually welded it into the tank, and they've put the enameling process over the heat exchanger and the tank on the inside. Now what we're doing is, with a glycol system, we circulate glycol up to the panel. It absorbs the heat from the sun. The glycol brings that heat that it's absorbed and it pumps it into the bottom of the tank. Now, by doing this, we are marrying the two systems, but we are marrying it automatically. The solar system doesn't know what the heat pump system is doing, and the heat pump system doesn't know if the solar is actually kicking in. Let me show you how it's done. Here you can see the solar heat exchanger. This is the sensor that tells the computer what the temperature is in the bottom of the tank. Now if the temperature up on top of the solar panel is warmer than the temperature in the bottom, this computer is going to work out the temperature differential and it's going to switch on the circulation pump. So if at the bottom here, if your municipal water coming in is colder than the panel, this computer switches on this circulation pump. And vice versa. The minute the temperature gets lower, this computer will sense that the temperature on the panel is lower and it will automatically switch this off. This is a very efficient system because if there's even 1 degree difference, if the panel is 1 degree warmer than the water in the bottom, it's automatically going to start the circulation pump, and we're going to harness the energy out of the sun and transfer it into the bottom. Now the secret of the system, or where the secret comes in, is that we are marrying these two systems without them knowing what the one is doing with the other. If cold water comes into the bottom of this tank, the cold water from the municipality is going to obviously rise up to the top. It's going to go past the sensor. If the sun is shining, it will contribute the heat into the bottom of the tank, and the heat will automatically, through specific gravity, it will automatically rise up to the top of the tank through the natural layering effect of water. When it gets up to the top here, you can see the heat pump sensor, which is a lot higher up on the tank. The heat pump sensor will kick in if you don't have any sunshine. Now, to give a different example, if you don't have any sunshine on a day when you've got overcast weather, or even at night, if cold water comes in the bottom, that will go past the sensor. The computer will not switch on, so the hot water will continue further up in the tank till it gets up to the heat pump sensor. Then only will the heat pump contribute energy. So as long as you have solar energy, the heat pump will never ever switch on. This is how you marry a solar system and a heat pump together. The trick is actually the vertical tanks. You cannot have this effect with horizontal tanks. That is why every single machine that we're importing from Europe comes in a vertical tank. We cannot buy horizontal tanks, and this is a problem that we have, in that we are trying to create some awareness in that if you want to save energy, you have to go for a vertical tank. This is the magic, this is where the secret lies of marrying these two systems. Alright, just to show you quickly some other features that this heat pump has. Here we've got a switch that pushes the water in the tank up to 60 degrees. It actually switches on an electric element over here. We push the water above the normal 55 degrees that the heat pump generates. By doing that, you kill off all the Legionnaires and the E. coli bacteria that grows inside hot water systems over time. You have to push this temperature up, say, once every 2 months to kill off the bacteria. The problem is, before alternative energy came along, everybody used to just have a geyser, and everybody installed it, they would leave the geyser. But the normal geysers used to be screwed up to 60 to 80 degrees, so you never had that problem. Automatically the high temperature would kill off the bacteria in any normal geyser system. But now, because we're going to alternative energy systems, the limitation on heat pumps is 55 to 60 degrees. And that is a problem because at the bottom of the tank we've got lower temperatures. You've got the chance of E. coli and bacteria growing. And to eliminate that, Germany has built in this button here that raises the temperature of the tank and kills off the bacteria. Alright, and an additional feature, we've got a timer in here, a day or a weekly timer that can switch on this element so that it can automatically kick in and raise the temperature once every, say, 2 months to kill off the bacteria. Then you've got your normal temperature setting over here where you can adjust the temperature of the heat pump. So basically what I've shown you today is a combination of solar and heat pump and integral system. This is the smallest system that we can offer, which we use for families of 4 or less in a house system. If we want to go and do hotels or bigger systems, commercial systems, we have to split the heat pump, and we provide individual tanks with heat exchangers that marry these two systems.